100 gigabit Ethernet has been the gold standard for high-speed interconnect both inside the data center and between data centers since 28 nanometer, first requiring 10 lanes at 10 gigabits per second in huge CFP modules, then moving to 4 lanes at 25 gigabits per second, which enabled smaller QSFP-style modules. Today, I'm here to show you a demonstration of the next step, 100 gig Ethernet on 2 lanes thanks to Xilinx 58 gig capable GTM transceivers and the Vertex UltraScale Plus integrated hardened 100 gig Ethernet subsystem. Let's have a look at the hardware setup for today's demonstration. The board is our UC1290 GTM characterization board featuring the VU29P FPGA. From there, we drive 2 lanes from a pair of GTM transceivers into a module compliance board. This allows us to use legacy QSFP direct attach copper cable to connect to a Spirent DX3 QSFP DD test module. Inside the FPGA, we are reusing the same integrated 100 gig Ethernet subsystem that has been production proven in other members of the Vertex UltraScale Plus family. Traffic is provided by pattern generators and checkers that are controlled by a GUI running on a separate PC. The integrated Ethernet IP drives into the GTM transceiver where the integrated 100 gig KP4 FEC has been enabled. The GTM then drives serial data onto the board. While the generators, checkers, and the transcoding block are implemented in FPGA logic, each of the other blocks is hardened in an ASIC-like core, keeping resource utilization for this implementation to an absolute minimum. The GTM transceiver is the first Xilinx transceiver to implement pulse amplitude modulation at 4 levels, or PAM4. This means that there are 4 possible voltage levels per unit interval, doubling the number of bits per UI while maintaining the same Nyquist frequency. This new signaling means a new architecture for the receiver, now featuring an analog to digital converter which, after a more traditional CTLE and AGC, feeds a DSP-based FFE and DFE to fully equalize the received data. Each piece of the equalization is auto-adapting to the quality of the input signal to ensure the maximum degree of performance over any channel. Our auto-adaptive equalization is working so well that Xilinx plans to continue using it for our next generation 112 gig transceivers. Of course, all the emerging PAM4 standards require forward error correction. While other products on the market are restricted to supporting FEC on specific lanes or are limited to only 100 gig implementations, every single GTM dual features a KP4 FEC block natively supporting either a single lane of 50 gig or spanning 2 lanes for 100 gig as we've done here. Because of the potent DSP-based equalization in Vertex UltraScale Plus GTM transceivers, and the fact that channel losses will be similar to 25 gig line rates, existing 25 gig backplanes and cabling can be repurposed as 56 gig media. This is exactly what we are doing with 2 lanes of the QSFP28 DAC in this demonstration, reusing what was originally designed for 25 gig line rates to carry 2 times the data. And we have been testing with a wide range of cables and backplanes to ensure your design will work when you move from a 25 gig based design to a 50 gig plus Xilinx GTM based design. The traffic being transmitted and received in this demonstration is being provided by the Vertex UltraScale Plus integrated 100 gig Ethernet subsystem. This is the same block that has been in other production proven UltraScale Plus devices. To meet the needs of these new applications leveraging 58 gig PAM4, we have increased the density of those 100 gig blocks in these parts from 12 to 15, an additional 300 gigabits per second of throughput. The advantages to integrating the MAC PCS and KP4 FEC are twofold. Each 100 gig interface saves on the order of 100,000 LUTs and time enclosure is drastically simplified. So let's see it in action. The GUI for the Xilinx side of this link shows that the device has achieved PCS lane sync, that the link is healthy, and that the GTM is transmitting a wide variety of packet sizes. You can also see that despite the legacy cable usage, there are 0 post-FEC FCS errors on the GTM receiver. The Spirent GUI shows that 100 gig traffic is being transmitted and received correctly as well, and on the next tab, you can see that the data is again being received with no post-FEC FCS errors. This means the 56 gig signal is clean in both directions. The clean communication channel is enabled by the strong equalization and the hardened FEC inside the Vertex UltraScale Plus 58 gig PAM4 FPGA. Combining the proven capabilities of the Vertex UltraScale Plus architecture and integrated protocol engines with the auto-adapting equalization features of the GTM PAM4 transceiver paves the way for the quick adoption of faster, narrower interfaces. Today, you saw 100 gigabit Ethernet, and these are the same transceivers and hard blocks that Xilinx will use for 50 gig E, 200 gig E, and 400 gig E. In fact, with a QSFP56DD connector, we can support all of these protocols on the same connector, facilitating backwards compatibility and reinforcing the reuse of existing infrastructure. That's the power of Xilinx and the UltraScale Plus architecture. For more information, please visit xilinx.com/58G.